Hello everyone, welcome back to my channel InfoSec Lab, and today we are going to continue our series of attacking and defending AWS services. Specifically, today we are going to cover STS credentials, which, if you recall, STS stands for Security Token Service, an AWS service that provides a short-term credentials for user to authenticate to AWS account. Alright, as usual, let's take a look at the reading materials. Understanding how credentials are generated and can be leveraged is critical for understanding how to attack or defend a cloud account or application. In this room, we will walk through the creation of a new IAM user and an IAM access key for that user. We will then use that key to assume a different IAM role to get temporary credentials. You can refer back to AWS API access key and how services get credentials tasks in IAM credentials room, which I'll link on in the descriptions. You can check it out. So from the above diagram, the IAM group, the IAM policy or permissions, and the role already exist. You will be creating the IAM user and long-term security credential. From your attack box, you will use the long-term credential to authenticate to the AWS Security Token Service to assume the role. The STS service will return to you the temporary security credentials required to authenticate to AWS as that role. If you haven't already done so, click on the orange Cloud Details button at the top right of the page. Generate the cloud environment and use the credentials provided to you to access TryHackMe Cloud Sandbox. For this room, make sure to start the attack box and prepare the AWS Cloud Shell in your AWS Sandbox account. We will create a user in the Cloud Shell, then simulate the exfiltrated or on-prem usage of the credentials on your attack box. The learning objectives of this room is to learn how to create an IAM user, how to create long-term access keys, how to export long-term access key as shell environment variables, how to validate the identity that is currently active, how to assume a new role using the AWS STS assume role command, and lastly, how to export temporary section credentials as shell environment variables. Task number 2 is just instructions on how to configure your AWS account. So on task number 3, first step is to create the Panda1 user. We will start by creating the IAM user Panda1. IAM users are the easiest way to grant access to a system outside of your cloud environment. Run this command in your Cloud Shell. IAM create user and then username Panda1. Okay. AWS IAM create user name Panda1. Yep. Okay, as we can see that the user has been created Panda1 right here. This is the user ID, and then this is the user's ARN, AWS resource name. Grant that user some permissions by adding them to the Panda1 groups. The command to be run is AWS IAM add user to group. Okay. Username and then the group name. Okay. I'm going to enlarge the screen right here. AWS IAM add user to group. Username Panda1 and then group Panda1. I think there's an S after that. Let's double check. Yeah, group name Panda1, username Panda1. Okay, set. Now that you have created a user identity, we will create the access key for the user on your attack box. In the next task, save the output of the create user command so you can validate your identity later. Okay, we're supposed to save this output. Open a notepad You know what, I'm just copy everything. Now this is useful because in real time you have to take note like what command you run and then what output it is shown to you. So in this case, the very first command I ran was this one, and then this is the output I got. And then this is the second command. So when I go back and review the steps that I performed, it's going to be easy for me to keep track of whatever I did or debug. Okay, run the command im list groups for users and then username. Okay, AWS im list groups for username pada1. Okay, we have confirmed that the user is in the group of pada1s. Great. What are the first four letters of the group of the pada1 group? Okay, the first four letters of the group ID is right here. Okay, hold on. Let me see. I think it's too small for you guys, right? Yeah, this one's much better. Next step, create an access key for the pada1. Having created the identity and granted permission by adding a user to the group, you have configured authorization for this user. In this task, we configure the ability to authenticate to the AWS API. To use the pada1 user on that tag box, you need to generate an access key like so. So on the Cloud Shell, we generate access key for the user. The command is AWS IAM create access key and then username. Okay, AWS IAM create access key and then user name is pada1. Right, so using the information above, go to your tab box and issue these two commands. Export AWS secret access key equals to this one. Okay, I get it. This is the secret access key. Copy and paste. Similarly, AWS access key ID equals to this one. All right. So what is the character length of the secret access key? It's this one, right? You can just Google. "43 characters." No, what? Okay. What is the character length of the secret access key? That's 43. Why isn't that correct? Why is it? Interesting. Let me double check. That is so weird. Let's see on the console. IAM, we have the users other one. Here we have the access key right here. Okay. Okay. No. Where's the cloud shell? I'll open it right here. That is so weird. It's 40. I don't know why it says 43. Phew. Alright. Next, validate your status on the attack box. Let's close this. So the AWS STS get color identity command is the AWS equivalent on the Unix command who am I? Okay. AWS STS get color identity. Okay, so we are currently authenticated as a Padawan user. Okay, on this system. Good. So moving into the next step, assume the role. Now that you've used a long-term access key for your IAM user, we're going to generate a short-term keys for an IAM role. In many attack scenarios, you'll be leveraging these short-term credentials, so it's important to understand the basics of this role credentials. The next step is assume the role of Jedi Master. So this is what we've done so far. We've got the policy right here. We have the group which already exists in the resource. And then we create this user. From this user, add this user to this specific group. So this pada1 user is added to the pada1's with an S group. And then we also generated a long-term access key for this specific pada1 user. Now we will be using this long-term credentials and then this user information to authenticate into the AWS STS service. Once we successfully authenticate to this service, we can actually assume the role right here and then generate a short-term credential for us. Alright. To do this, there are three things. The permissions to assume the role Jedi. This is provided by the policy attached to the pada1's IAM group. Refer to task number 2 where we added this user to the pada1 group. So this permission has been already provided in this policy right here, so we don't have to worry about that. The Amazon resource name ARN of the role you want to assume, this will be the ARM account ID, which is our AWS account ID, role, and then Jedi. A role section name, this string will appear in CloudTrails and help administrator distinguish who or why a specific role was assumed. For this, we shall use the name of someone who almost became the Jedi Master. Okay. So the command line we use is AWS STS assume role. The role ARN is this one. And the role section name is Ahsoka. Okay, so first of all, we have to get the account ID right here from task number 4, which is, what was the account ID? This one. Alright, that's going to be account ID. Let's start AWS STS assume role name. Oh, we're going to copy this one. Role name is, no, it's not role name, role ARN. And we're going to paste these values in, and then the role section name Ahsoka. This role section name is only appear in CloudTrail for us to actually monitor the activity. Alright, let's double check the syntax. Everything looks correct. AWS assume role. So right now, because you have already authenticated as pada1 user, you can actually run this command, and then this command will actually use your current login user to assume the role Jedi right here. And as expected, we are returned with different set of credentials: the access key, the secret access key, the session token right here. Okay, so we have copy this and keep it in the node right here. Now check the output of assume role command and set the 3 AWS CLI environment variables required to use temporary credentials for the role. Okay, now we can try to log in the assume role as a Jedi. Let's see if it works. Export AWS secret access key equals to this is the secret access key. Okay, export AWS access key ID equals to this value. And last but not least, AWS section token equals to the whole string right here. Okay, now let's double check if we authenticated as a Jedi. STS get caller identity. Here we go, soccer. Okay, how many minutes does it have? Expiration. We created. Let's see. Okay, so okay, let me try to figure out how to see how minutes are the session credential good for. Interesting. Let's take a look back at the values right here. What was the command for tab? Let's see, date. What's the date? Okay. So I assume that we created the temporary session token key around 7:38, or yes, around 7:38 or 7:35, about 3 or 5 minutes ago. And then the expiration day is it shows right expiration. It's Monday, December 7th. So the expiration day is 23rd. Okay. Yeah, December 23rd. And then expiration 8:35. So it's 60 minutes an hour. Yup. Wow. How many AWS CLI command variables were required for it to be set? 3 in this case. Secret access key, and then the session token. Alright, and then last step, validate your newly found powers, which I just ran right here, AWS STS get caller ID. This was reasonable simply exercise. However, the things we've done here are fundamental for understanding the credential exfiltration techniques we will do in later rooms. As a defender, it is very important to be able to recognize credential string when you see them in your source code or bug bounty reports. Best practice is to avoid using these long-term credentials. What IAM resource does the string begin with ARA represent? We can just Google. IAM role. Okay. Okay, cool. We have completed the room. Next. Okay, let's go back. Okay, next. Close. Okay, so that's it for the room today. So basically what we did is to create a user with a long-term credential, which is the access key and the secret access key. From that, we authenticate that user to the STS service, which is the security token service. From here, because the user has successfully authenticated himself, then the service will grant the user a temporary credentials to assume the role of Jedi. So assuming that Jedi is the admin from the developer, from the development team, then this Padawan user will have all the permissions that the Jedi admin has over the developer team. But because this session token is only available for 60 minutes, so this Padawan user only have all the administrative permissions for only 60 minutes or an hour. By doing this, we can actually protect the credentials of the real Jedi admin, because the access key from this STS service, is completely different from the Jedi admin's access key. Alright, so that is how we temporarily assume a role in AWS and then perform some administrative functions. And hopefully it makes sense to you. I know it may be a little bit confusing for a lot of you guys, but don't worry about that. If you have any questions, feel free to reach out and I'll be happy to help you with. Alright, thank you very much. I'll see you next time. Bye.